Hi everyone, I am Rekha, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science. So, today we are going to discuss the topic Problems in Queuing Theory, M/M, NFIFO. So, this is from the subject Resource Management Technique. So, this topic covers in the Unit 3. Okay. So we can go previous video we have discussed about the queuing theory and its characteristics and the basic definitions of the queuing theory, and also we have discussed some of the problems in the queuing theory. So this problem is based on the model 3, and in this model we have a finite number of customers will enter the system. Okay, so let us see one problem. A railway station, only train is handled at a time. The railway yard is sufficient only for 2 trains to wait, while the other is given signal to leave the station. The train arrives at the station at an average of 6 per hour, and the railway station can handle on an average of 12 per hour. So normally we are going to find the average waiting time of a new trains coming into the yard. So now for all the problem we have to find the arrival pattern and as well as the service pattern. So arrival pattern normally represented in the form of an lambda, whereas the service pattern is represented in the form of an mu. Okay, so how many trains arrive for an 1 hour means, so approximately 6 trains will arrive within 1 hour. So we have to convert the hour into minutes, means 6 by 60, because hour into minutes we have to divide it by 60. So if you cancel, you will get 1 by 10. And if you go with the service rate, it is used to denote with the word mu. So here also 1 hour, for 1 hour 12 trains is getting service. So this is also we are going to convert into 1 minutes. So 12 by 60 you will get, if you cancel in the 12 table, you will get 1 by 5. So next we can find the average waiting time of a new trains coming into the yard. For that we have to find the number of trains, that is yard capacity, that is n equal to 3, and for all the problems we have to find the rho lambda by mu. That is lambda by mu is nothing but lambda is 1 by 10, whereas mu is nothing but 1 by 5. If you reciprocal, we will get in 5 by 1. So the final answer is 1 by 2. The 1 by 2 if we denote means we can say it is an p equal to 0.5. So p naught equal to 1 minus p by 1 minus p whole to the power of n plus 1. So already we have found that p is equal to 0.5. So 0.5 in whole to the power of 3 plus 1. Okay, so 3 plus 1 is nothing but 4. So 1 minus 0.5 the whole to the power of 4 can rise using the calculator, 0.0625. 1 minus we will get 0.9375. So again 1 minus 0.5 will get 0.5. So if you divide 0.5 by 0.9375 means you will get a value as 0.53. Next for the n values we have to find. So how many trains are the capacity the yard? You have the 3 trains, so you have to mention for P1, P2, P3. So the P1 formula is P1 into P0. So 0.5 into, already we have find that P0 0.533. Multiplying this two value will get 0.2527. Then P2 equal to P2 into P0. P2 is nothing but 0.5. 2 into 0.533. Multiplying this value will get 0.13, and so on we get the value for P3 also. And the question is nothing but you are going to find the average for this value. So average is nothing but expectation, that is E of n you are going to find. So summing all the values of this you will get 0.733, that is 0.5 into, you have to calculate using this formula, 1 minus 0.125 into 4, because 1 plus n is nothing but 4, and similarly 3 into 0.5 whole to the power of 4, then you will get 1 minus 0.5 into 1 minus 0.5 whole to the power of 3 plus 1. So if you simplifying this value you will get 0.733. This is your average. average waiting of a new trains coming into the yard. Okay, so next we can see the another problem, that is nothing but a barber shop customers according to the Poisson distribution with an arrival rate of 5 per hour. His haircut time is exponentially distributed and also 10 minutes. So we have to similarly we are going to calculate the average number of customers in the shop and average number of customer waiting for a haircut. So this is your same method you are going to follow. So as an assignment you solve this problem. Okay, so this will be a good practice for you. So previously we have discussed the same method no and also formula. So same concept you can try this problem. Okay ma, thank you.